Hello and welcome back to Cracking the Cryptic and happy birthday Math Pesto. Now, if you're wondering, Math, how we knew it was your birthday, well, your partner Mick wrote to us and suggested that we do one of your puzzles on the occasion of your birthday. So very happy to do that, and I have Japanese sums with arrows as recommended up on the screen, and we're going to give that a go. Now, be warned to the other viewers, anytime we have done a puzzle by Math Pesto in the past, it's been pretty difficult, so this could be a long one. Also, I note that there are no given numbers anywhere in this puzzle, just some arrows. And although I like Japanese sums, I don't think this makes it easy at all. So I'm looking forward to it, but with some trepidation. Now, that said, do be aware that we are going to be doing some quite approachable Sudoku for our February monthly reward. So on February the 1st, we'll be releasing some puzzles themed on our apps, which are quite approachable. So this is the time to join our Patreon if you like puzzles that you can probably do. And if you've struggled in any way with the puzzles in the last 2 or 3 months, which have been pretty hard in some cases. So that will be the Patreon reward. If you're on Patreon, you can watch Simon solve a Fistemafel. That's back in the hard puzzles genre. But if you like the approachable ones, there's not only our own apps, but there's also the Grand Prix Sudoku, which still has the WPF Grand Prix Sudoku, which still has a day left to run. If you search for WPF Sudoku Grand Prix, you can find that. So loads going on as always. Do check out our links for our merchandise, our apps, the Discord server, how to get to Patreon. All of that stuff is on there. And so is the link to this puzzle, which you can try. Now, in our software, yeah, okay, there are limitations here. So this is the 9x9 grid that we're going to solve, but I don't think our software will mark this right because we have also got these clues outside the grid in the white cells. And let me explain the rules of this puzzle. So within the main 9x9 grid, normal Sudoku rules apply. 1 to 9 in every row, column and box. That's fine. Numbers along an arrow must sum to the number in the circle. So those two cells add up to the number in that one. Okay, now the Japanese sums bit. We have to shade cells within the main 9x9 grid so that the clues outside the grid equal the sums of the digits in contiguous blocks of shaded cells in that row or column. Now let me explain. If we had a 9 and an 8 in the final column here, that might be, for instance, 4, 2, 3, and that might be an 8, and they might all be shaded cells, and these others would be unshaded. So we'd have this pattern, and these clues would be adding the first block of shaded cells in the column, and that's those 3, and they add up to 9. That's adding that one, so that's 8. And that would be one way of filling this final column. But obviously we know nothing about it at the moment, but that's a possibility. The number of clues for a particular row or column. Oh, first of all, in the rules, math says that blocks must be separated by at least one unshaded cell. So that bit is separating the blocks here. Then there's a couple of notes. The number of clues for a particular row or column is exactly the number of white cells outside the grid for that row or column. So there are no missing clues up here. If this is the pattern, there will always be 2 clues. Also, numbers outside the main 9x9 grid don't have to adhere to normal Sudoku rules. They can be greater than 9, including in an arrow's circle, and can repeat in the row or column, etc. So we could have 2 9s in this column, and that could be a 9, and this doesn't break the rules here. Or this could be a 12 made up of 2 6s, say. Now, I'm not sure I can write 12. I could write it like that, but you know, hopefully it won't matter too much. We'll find a way of coping with that if we need larger numbers in this puzzle. So that is how the puzzle works. Do give it a try if you feel up to it on the link under the video. Maybe it's not as hard as I'm making out, in which case hopefully you'll be able to judge that from the video length. But the first link is to the puzzle. I'm going to try it now. Let's get cracking. And I was going to start by looking at these long arrows. If if we hadn't just had that rule about how these can be the same, I would have said that this has to be 9. That's a set of 1, 2, 3, the minimum for one box that are different. And that would be 1 and 2. Oh, okay, actually I can say that. Right, but what I was nervous about for a second was that they could both be 1s. But actually that doesn't make sense in the column. With a very low number, there is only one way of having a block of 1, and that's to have a 1 somewhere. But you can't then have another 1 in the column. So it's not 1 and 1. That is 1 and 2. That's 1, 2, 3. This is a 9. The only shaded cells in this column will be a 1 and a 2 in some order somewhere along it, separated. In fact, somewhere along it is not in these 3 cells, because we've already placed, in a way, 1, 2, and 3 in this box. So the 1 and the 2 will be down here somewhere. Now they could be there, or one of them could be on the 9 arrow. Now we've got the same arrow here in a slightly different orientation. But again, we can put 9 there, 1, 2, 3 there, and a 1, 2 pair here. And that is quite a handy start. Yeah, the trouble is I keep looking at that 1 and 2 and trying to relate it to that 1, 2, 3, but they have no relation to it. Oh, and this is another. Yes, this again, does this have to be 1, 2, and 3? 3 could repeat, but not with 1 and 2. So actually, yes, that's fine. Again, we can do 1, 2, 3 there. 1, 2 pairs in the other bits of the arrow. That's all right, and this is a 9 as well. So we've got 3 9s in the grid. Feel blessed. Now, what else is that telling us? Again, that's telling us that in this column and this row, the only shaded cells are 1, 2, and 3. So the 9s, actually, in all the ones we've done, are not shaded. Oh, that must be shaded because the 1, 2, and 3 in this row is shaded. Same for that. So I'm going to go with this dark grey for shaded and green for not shaded, as you see. Now that doesn't have to be shaded because it might be a 3. And only, well, I mean, it might still be shaded, but only 1 and 2 definitely have to be shaded in this column so far. So I don't think this gets us much else done. Oh, hang on. Okay, so these 2 cells can't contain 1, 2, or 3 because the box has used them up already. So that's the third one. These are green. And then the first 2, well, one of them's in those cells. One of them's in those cells. Okay, I don't know much about that still. But these are green as well by the same principle. We can't get another 1, 2, or 3 shaded in here. In fact, these are green, just realized, because these are individual totals. So they're individual cells being shaded. So actually one of 1 or 2 is there and the other one is here because we can only get 1 in each of those. So right, so there's a 1 and a 2 in those 2 areas. I don't know which way round. Oh, I was going to shade the rest of these green, but actually, no, I can't do that. I know that they don't contain 1 and 2, but that doesn't mean they're unshaded. Actually, it does here and here. Those are green. Okay, because although 1 and 2 are confined to those areas, the first 2 shaded blocks in this column are 1 and 2. So if that was shaded, it would be part of that block. Well, or that block. I mean, that's a little bit, I want to say advanced. It's a little bit convoluted. Oh, good grief. I've just noticed there are no clues in the central column and row. So they're all green because we're told we're given all of the clues. So that, wow, well, that's coloured a lot of the grid suddenly. Right, bingo. There are 4 clues in this row. And we've made this green. So if we didn't have 2 blocks in this first section right there, then how could we fit 3 blocks into this section? We couldn't. if you have 3 blocks separated by cells, that's at least 5 cells. So we get 2 blocks there separated. Same's true here. There's a lot of symmetry going on. We get 2 blocks there separated. Now it doesn't tell me, there's 1 block confined to those 2 cells and another one confined to those 2, but they could be 1 or 2 cell blocks. Now does this have to be a 1 or 2? No, it could be in the 3rd section and it could go longer. I don't think I know much about that. Right, but now in row 1 I do know where the shaded blocks are, and in column 1 there they are. Those are green, and in box 1 that is a 1-2 pair. And the next one is 1, 2 or 3. And this is green because that is on its own. This, however, could be the second block being a 1 or a 2, and that could be if that was a 3. Gosh, this is a strange puzzle. Now, we've only got 2 cells there and 4 there. Oh, these aren't 1s or 2s, are they? So they're not shaded in those rows and columns. Right, so there is 1 shaded cell, but, well, yes, 1 shaded cell there, 1 shaded cell there, 1 there, and 1 here. Oh, this can't be where 1 and 2 are. Right, I was wondering, does this have to be shaded? And it does, because otherwise 1 and 2 would be in those 2 cells, and then in the row you couldn't get one of them into the final box. So that is shaded, and the same applies to the row. That's shaded. Those are green. Is it this one or is it those 2? I don't know, but those 2 are a 1, 2. Well, they're both 1 or 2. I was going to say pair, but I don't know that. That has to be 7 or 8 to make up the total to 9. Now, in this column, yes, that's great. If this is shaded, that is the 3rd segment. Same is true for the row. Those are green. I don't know about these. Don't think I've got the information. Now let's have a look at this row where there are 4 again. So there's number 3 in either 1 or 2 cells. There's number 4, and it must be, so I can shade that, because 1 and 2 must be confined here. So here again, that's shaded. Don't know what the number is, but I've got a lot of the grid coloured now. That's quite a good advance. Still don't know which is the second and which is the 3rd shape here. Now in this row we have 3 shaded areas. The first one has to be confined into there, so these 2 are definitely shaded. Same's true down here. Those 2 are definitely shaded. So the second one is a 1, 2 or 3. Same here. Does that tell us anything? Gives us a bigger area here, 2 cells, and that's this one, which is adding something confined to there, which is that one and this cell. Oh, this is strange. It's such a strange puzzle and way of looking at things. Now in this column, we really don't know. That could be all the same segment, and then you'd have 2 and 3. Same's true here. Probably going to have to do some Sudoku in this Sudoku in a minute, but I don't really know how to go about it. So let's have a think about these cells. Is that the remaining 1 or 2? Then these would be the same as each other, necessarily. These would be the same. Don't see a problem with that. This one is the total of the two areas above it, which certainly don't occupy 4 cells then. It doesn't really tell me anything. Okay, need to think of something now. It's hard to see what I've got to go on. In this... I was going to say in this row, the 3 areas have to add up to a circle. Now that could be there, but it could also be that or both of those. The fact that it can be both of those gives it a maximum number of 12, in which case this could be 4 cells coloured. So I don't know how that works. Bother. 4 in this column, so those include the second shaded block. Wow, I don't know how to make any progress here, and it's really baffling me a bit how we're ever going to get to any numbers in this puzzle. Like, it's all very well shading areas, and we've done a fair amount of that, but haven't coloured anything or seen how I can do it yet. So, sorry, I haven't numbered much or seen how that is going to come about as we go through it. So I'm feeling a bit stuck at the moment, but let me think a bit more. Oh, right, here's something interesting as well. This cell is a total that comes from either that or these two. And these are very confined, and I've suddenly realized that this cell is confined because it's either the second block going down or it's green. And that means if it's shaded, it's a 1 or a 2. And that means this is limited to a maximum of 5, because it's either this cell on its own or it's both of these, but this is 1 or 2. So the most this can be is 5, but I'm going to say the least it can be is 3, because it's adding the next 2 blocks. So those 2 blocks clearly have to be 1 digit each, because this doesn't go up to 6. So that's one of them, and it's on its own. The other one is one of these 2. Now there is a way for this to be 3. And that would be 3. And that's if the next 2 blocks were 1 and 2 in some order. Now, does this doesn't apply here because we've got a different arrow. Although it actually, well, no, we've got a single cell, but it could be an 8. So that could be adding 3 cells. So I can't make the same jump forward judgment. So this is either grey and 1 or 2, or it's green. Oh, if this is green, that has to be a 3, because this one is confined to 1, 2, or 3. So if this is green, we've got 1 or 2 in that range of cells. And this one would always be 1 or 2 then. Whereas if this is grey, this could add up to 5. Actually, it couldn't be 4 because 3 and 1 would need 3 and 1 to appear in grey cells later because of this relationship. Good grief, this is complicated. But it could be 3 and 2 with a 4-1 pair, which would be in those cells. So how is that going to work? That could be either way round. It could be 1 and 4. But this is always confined to... It's either 1 or 2. Actually, it's either 1 or 2. Or it's a 4. So it's actually not 3, I don't think. I think it's 1, 2, or 4. And that is the second cell here. And this one, do we know anything about this? Well, it adds to... Those two added together give that number, which also can't be 9. So these two can't add to more than 8. Sorry, I've got something in my eye now, which is annoying, but I'm trying to battle on. Maybe I'll just keep it closed for a while. These two add up to 8 or fewer, and that's those two cells. So neither can be more than 7, and that includes this cell. That's not helpful. I don't think it's helpful. Oh, there's something going on. There's more going on here. If that was a 2, then what would happen? We'd get a 1 here, 2 here, 3, 2. This would be a 1, 4 pair in these two cells. They are all likely to be grey and low though, so I don't quite know how that works. Oh, 9 is confined to these two cells. And these two, just by Sudoku. Oh, look, in fact, I can place a 9 here because 9 in this box is in one of those two, so that's not a 9. Is that any use? I don't even know if it's shaded though, so, and it's not, it doesn't feature in any relationships, so it's not all that useful, unfortunately. Oh, here's a thought. 3 is in one of those cells. It now isn't in those, so it's in one of those cells, and therefore it's in one of these two. It can't be there because of that 1, 2, 3. So 3 is in one of those two, but surely the same is going to work vertically. 3 there means that's not a 3, and suddenly we get a 3 here. And it is not shaded, so that is green. And the shaded cells in this row and column are there, and they're a 1, 2 pair. So now we're getting all kinds of 1, 2s around the grid and some relations between them. I'm wondering if it's worth colouring them. But I haven't got much going up here, so probably not yet anyway. So these are different now because those are different and they each see one of these. These are different, so these are different as well. What does that tell us, if anything? I can't even fill in that the last one here and here are a single 1, 2 because these could be grey, so that doesn't work as a relationship. Here I don't know because I don't know whether that, which group that's from. I'd really like to know about this cell. Is there a way of working out whether this is 1 or 2 or something? Just don't know. Sorry, this needs thought and I'm not getting very far at the moment. What on earth can I do? What haven't I noticed in the clues and their setup? No, the maximum for this number is, well, it's governed by the maximum for this, which is 8. So the most that grey cells here can add up to is 8. I don't know what to do with that information. Oh, crikey. This is what math does. He just absolutely blows you away. Right. This cannot be the second grey in this row, I reckon, because if it were, oh no, it can't on its own because it would be 1 or 2. Oh right, no, that's okay. Neither can this be the second grey, nor can this pair be the second grey, because the second grey is 1 or 2. If that was 1 or 2, that would put it in the circle, and that doesn't make sense. Even though you could repeat 1 in those cells, you couldn't repeat 1 in those cells. That is not 1 or 2. Therefore, this is the second grey in the row and is 1 or 2. And I don't know if this is going to help. Well, it colours this column. Green there, grey there. Now that means that those two add up to, well, maybe, and that cell add up to that one. Ooh, how could they be 8 or less? I'm just wondering about this being green. If they were 8 or less, yes, actually that could be a 1, 2. No. No, they can't be 8 or less, because if they were, they would use 2 of the digits out of 1, 2, and 3. If there were 3 cells adding up to this. So that's not grey, that's green. And now these two add up to that, and that's perfectly doable, even with these being low numbers. Right. Now this has become a 3. It's got a 1 and a 2 in its row. But I don't know what colour that makes it. It does mean this is the third segment, so this is green. Could still be a 9. And I don't know whether the third segment is 1 cell or 2, but that is the sum of all the grey in this area, in this row, and we know where those 3 are now. And the sum of those 3 is equal to either that cell or that cell plus 3. This has to be at least a 3. This has to be at least a 4. And that has to be at least a 1. So they do add up to at least 8. But the most they can add up to is 12. 4 degrees of freedom, that's not actually all that helpful. Now these columns. Do I know in this column? I still don't. That doesn't have to be grey. Oh, hang on though. This, yes, the sum of these we know is 3, 4 or 5. So it's got to be 2 individual cells. That is green, right. So we do know about that, and that's the first one. This is 1, 2 or 3. Right, so those 2 cells, I was going to say add up to that, but it could be to that or both. And I still don't know if this... Well, maybe I've nearly connected up my 1s and 2s. So this first thing is somewhere between 3 and 5. These next two, they either use something from 1, 2, 3. Well, they do use something from 1, 2, 3. They use the third digit from 1, 2, 3 because they can't be 4 and 5, or that would be 9, and that's too many. So the other digit from 1, 2, 3 is in one of these 2 cells, along with something higher that's 4 or 5 or more. And all that's telling me is that this is 5, 6, 7 or 8. I can't get more out of it than that, unfortunately. Oh, those aren't 3s now. Ah, so the 3 in the top row is there. So this is now 4 or 5. I mean, this is a useless number to fill in, but it is 4 or 5. Is the same applied over here? No, I have not worked out that that's a 3, because I don't know whether 1 or 2 are confined there. Ah, come on, keep thinking. In this box, 1 or 2 must... Oh, 1 or 2 must be in one of these cells in this box. Because we've had 1, 2 pairs in rows 1 and 2. Ah, and it's not here because the 1, 2 and 3 are in grey cells. I worked that out a moment ago. Now, can I work out here? These two add up to that one, which is no more than 8. Does 1 or 2 have to be used in these cells? I think it does. Although 8 could be 3, 5, that's impossible here. I suppose 7 could be 4, 3. Very nearly reached a conclusion that 1 and 2 must be used in these 3 cells and therefore doesn't appear here, in which case I could mark that as a 1 or a 2, but I was unable to reach that conclusion. Bother. Okay, I know this is more than 3 because of this triple, and this one is more than 3. So this is quite a big number. This is at least 9, which is unsurprising. I mean, it could be, well, that could be 24, so who knows? Oh, come on. Let's do some thinking. Let's work this out. What on earth? The most this can be is 7. 7 plus 1 is 8. 7 plus 1 is 8. All too possible, and indeed plausible. What about 9s? Maybe I'm looking at the wrong end of the spectrum. Could that be a 9? No. No, that can't be a 9. There we go. That is a good question, because this can't be a 1 or a 2, and the maximum these can add up to is 12, which would be there. So that can't be a 9. In fact, that is a 1 or a 2. Yeah, this is right, isn't it? If these can't add up to more than 12, that can't be a 9. That is right. So 9 is placed here. Then we get a 9 in one of those 2 cells. I don't know that this did anything at all, but it feels satisfying to put one more number in the grid, frankly, in this puzzle. Can I do the same down here? If that was a 9, well, if it was grey, then those 2 cells would add up to 9. And if it wasn't, that would be no more than 8. Oh, it might be the same sort of thing here. If those 2 can add up to a maximum of 12, that doesn't help actually. Maybe I can rule this out from being a 9. No, I can't. I think I could rule it out from being a 9 if I knew that was green. No, if I knew that was grey, if I knew they were both shaded and added up to at least 10. No, even then this could be 7 or 8 and get the job done. Right, that's no use. Oh, goodness gracious. Got to keep thinking. So in column 6, did I decide that this has to be... No, I looked at this. Did this have to be 1 or 2? No, it could be a 3 if that's a 4 and that's a 7. Now if that's happening, that's a 4, so that can be a 1 and this can be a 3-2 pair. Oh, hang on, I don't think this works. If that's a 4 and this is a 1 and this is a 3-2 pair, so then we've put a 1 here. That 2 would force a 1 here, which forces a 1 here, and that's impossible. So I don't think this can be a 4 at all. If that was a 4, it's so we can have a 1 here to make this 5 out of 3-2, but that forces 1 here, 2 here, 1 here, which clashes. Right, that's not a 4. Can this still be 4, 1 this way round? Then you get 3, 2, 1, 2, 1. And then you've got 4 plus 2 there equals 6. Ah, that does work. 2 there makes that a 1. Oh, good grief. So close to getting a breakthrough there. Oh, hang on. Where's the second 1 or 2 here? It's either there, where it could be a 2, or here, where it could be either. It's not here. This can't be a 1 or a 2, because it would have to be a single cell on its own. That's a 3. How long has that taken me? Good grief. So that's a 3 in column 1. So 3 by Sudoku in box 1 is there. Given that there are 4 3s looking into the box, we can work that out. So we've actually established a couple of 3s. Now that's 1 or 2. And we even know some clues. Now, do we know that it's green or grey? Probably not yet. Oh, good grief, that took so long to see. Now, this is either 3, it's not 4 anymore. If that's a grey 2, then we get 4 and 1. If it's green, then we get a 1, 2 pair. Right, now though I am going to colour things just to see where we go. So let's make this a red 1 or 2 and this one a blue 1. And that's red. Those 2 are blue. That's red. That's blue. I have a feeling this is petering out at this point. The red 1 or 2, it's in one of those 2 cells. But I don't know which one. I know it's not there because we've already got the 1, 2 pair in that column. In fact, here, where's the other 1 or 2 in the bottom row that's not there? It's not here or here because 1 and 2 are done in that box. It's not here because 1 and 2 are done in that column. It's here, and it's green. And I don't know if it's red or blue, do I? I don't want to mark these in green and purple down here, even, or purple and yellow or something, because I just thought we were getting there. Right, how about the 1, 2 in this column? Yes, it's not in those cells, or, well, one of them's in those cells. But I don't know about these 3. Can it be there or there? I don't know. Right, think again. Come on, keep going here. Where's the red 1 or 2 here? Anywhere there. And the blue 1 or 2 is in one of these cells. Now, yes, this cannot be the red 1 or 2. I think I worked out earlier that these 4 have to include 1 and 2 to make that work. I'm gonna remember that I did work that. I'm sure I did. So that's not red. So this is red. Right. So it's not a 9. That's the first thing to say. Next thing to say is it is a 1 or a 2. Let's point out that that gives us a 9 here. It's going to give us a 9 in one of those cells. I thought it would do more. But red there means this is blue. This is red. Now we can trace this around. Blue, red, blue. And now we need another red one somewhere here. And here, and here. We need another blue one somewhere here and obviously here. And in fact, that gives us the last blue one in that cell. Crumbs, there's a lot of this done, and yet I don't really feel I've made much progress somehow. This is Math Presto for you, ladies and gentlemen, even on his birthday. He can be beastly to us. Oh, look, 3, 3. That's a 3. I don't know its colour, but I know it's a 3. One of those is a 3, so they're now a 9-3 pair. One of these is a 3. Making an X-wing with 3s. Do I know about these 9s? If that's a grey 9, well, that plus this is 10 or 11. So this would be 7 or 8, and that would be grey. And if that was grey, those would both be grey. Ah, in this column, oh no, I don't know what this is. Oh, ooh. I do not know how the greys and greens break down. I've only got, what is it, 6, 9, 10 white cells left to colour, but I am so short of ideas about how to colour them. Now that's not 1 or 2. Maybe it is down here. So I was wondering if that was 9, and it seemed to be possible. If that was 9, that would make these 9. That's fine. This would be less than 9. Maybe I need to wonder if this is green. Then that's a single cell in the circle. And those two add up to that. Okay, this is at least a 4. So this circle is at least 5. Oh, I was just at least trying to rule out red 1 or 2 from there. And I can't even do that. Wow, this is not easy, is it? So those 2 or 3 cells add up to that one. Maybe I can use the fact that I've got these 1, 2s sketched in. Everything else is bigger, isn't it? So along here, 3 plus at least 1 plus at least 4 is, and it is only those 3 cells, is 8. Can that be grey? This would be up to 5, but it could only be 4 or 5 if that was the case. And the alternative is you add that as well. But the trouble is this could be a lot bigger. This could be a 7, and then, for instance, these could make 11, and that would be an 8. That doesn't really get any parsnips buttered or anything. Oh my goodness. Okay, this one down here is 5, 6, 7 or 8. That is the sum of these two, one of which can be 1 or 2. The other has to be higher than 3. So one of them is 1 or 2. One of those is red. Oh, and red is one of these because it's a 1 or a 2, and it's either a 2 in that cell or it's in that cell. So, oh, so that's a sort of X-wing on reds. And the red in this row has to not be there because of that. So this is a red 1 or 2. Good grief. I mean, it's logical. Maybe it's viewable by somebody very clever, but I'm not that person today. So 9, 9, oh, this is a 9, that's nice. We get the last 9, here it is in the grey cell. That is a 9. Aha! So 9 plus 1 or 2 is 10 or 11. This cell is grey. But the trouble is, I do not know if it's also red. Red 1 and 2 are still in an X-wing, but this is either 7 or 8, depending on whether that's 1 or 2. That's right, isn't it? 10 or 11. Yes, 7 or 8 there. Not that that does me any good in the row, but 7 or 8. And this is grey. That's what I learned. That was the important thing, and I didn't mark it. So we get a 6 as the total here. That is the first thing. So these two are both grey. The second one is a 9. That's just housekeeping to mark these in. They're not going to actually matter to the solve. All the 9s are in the grid. All the 3s are in the grid. Almost all the 1, 2s are marked, apart from my little X-wing of them. 4, I can suddenly see, must be in one of these cells. It's not that exciting, but it's true. So this pair adds up to at least 14, which is the total of that cell on the arrow and some group of shaded cells in this area. Oh, this last thing here is either 1, 2, 4 or 5. Is that? That's not any use. Oh, maybe here though. This one is also 1, 2, 4 or 5 plus that, which can't be 1 or 2 or 3, equals this. Oh, but the trouble is this can be as low as 1 or 2. So that's 4, 5, 6 or 7. This is 5, 6, 7 or 8. And that doesn't actually, oh, hang on. Okay, that's also here. 4, 5, 6 or 7. So this can be anywhere between 5 and 8 again. The only way this is not the red 1 or... Oh, that's not a red. Is this 7 or 8 right? Yes, that can't be red. I've gone mad. I can't see ordinary things now. So we've got the reds. This is red. But I don't know still whether it's green or blue. Green or grey. That, however, is green or grey. So that's a 1 or a 2 there. That's 4, 5, 6 or 7. And that's in this sum, making this one somewhere between 7 and 4. Oh, but that's here. Well, it has to be a 4. Right. So this row's done. 4. Well, it's done in the small digits. And now we know that red is a 2. And that is grey. Wow. Okay, so that is grey and red. Red is 2. Can I... No, it's not. It doesn't like the colouring. Right, I'm going to flick around, getting lots... I mean, probably quadrupling or more the number of digits I get in the grid, because I can fill in all the 2s and all the blue 1s now. And that feels like real progress. Even if it's not, it really feels like it. So 5 is the sum of 4 and 1 there. Let's fill in these that I can. That is 3 and a 1. Ooh. No, we'll get back to that in a moment. 2 and 1 there. Up here we've got 1, 3, 2. Down here it's 2, 3, 1. Then 1, 2, and either 10 or 11. And I don't even know how to write those when I get there. Down here, 3, 2, 9. Down here, 4. Not that that matters. Then 4 and 2. That does matter. They add up to 6. So we get a 6 at the bottom. This hasn't really, oh, it can't be 4 anymore in the box. So this one can't be 5 anymore. That can't be 4 anymore. Now, right, since this can't be 9, that's not grey, because the minimum for those would be 9. So that's green, that 3. And these now add up to 6, 7, or 8. That's not 5. This is a 1. There we go. I don't know what this is, and it doesn't really help. 2 and 1 there. In this, something that's 15 or another cell more. I don't know what's going on in that row. We'll get to that in the end, hopefully. Oh, breathe again. That one's 10 or 11. Okay, down this column. I don't know why I didn't do that. 2. No, it could still be 6 at the top. Right, do I know about this? 3 plus 1 plus 4, 5, 6, 7, or 8 equals, well, it could just be, that could be green if this is 8 and that's 4. That's really annoying. Right, this is either 2 or 5 at the bottom. That's 5, 6, or 7. Again, this can still add up to 6, 7, or 8. I don't think this, oh, that's a 1, definitely, yes. Yeah, I've done the maths right, just not done the housekeeping. Right, come on, let's mark some things. So 5, 7, and 8 still to go in that column. What should I be looking at next? Just don't know. That is 1 different from that. Ah, interestingly, there can't be 7 there and 8 there, or we couldn't fill that cell. So that at least takes 1 possibility out. That takes 1 possibility out here. This can't be 8. These two are going to be the same. I hadn't noticed that before. Does that have any impact? Not quite. Keep going though. Keep going. Stuff is coming. Gradually. Softly, softly, catchy monkey. This pair, the most they can add up to is 10. 3 plus 1 is 4. The most this can be is 6 now. Still, that could be, no, this can't be 8. So that can't be a single cell. That is grey. Yeah, 3 plus 1 plus 4 is the minimum, and the maximum for this single cell would be 8. So that is grey. That is needed. This sum is either 9 or 10. Minus those 4 is either 5 or 6 there. Okay, so we're getting some reduction. Now we got that as grey, so we put in a 6 there. This is the second grey in the column is a 9, and that is grey. 1 more cell done. Just 3 white cells on the bottom row still to figure out. Now, what is going on the bottom row? That plus the sum of whatever's in here and any other grey cells equals the sum of what's ever in here and maybe that. Ugh. Right, never mind about that. 6 there gives us a 6 in one of these cells and a 6 in one of those two. What else? 3, 2, 4, 1, 9. 4s. Is that the only? Okay, 4 there means 4's in one of these cells. Doesn't look very helpful, but something's got to help here. There's still a way through this puzzle. Wow, what clues have we got left? Oh, these have become done for ages ago when I did the colours on blue and red. 8 there, 7 there. So that's not a 7. In fact, this is a 5, 4, 8 triple. This is a 7-6 pair. So the last is 6 or 7. I was going to rule out 6 because of that, but it's got nothing to do with it. I don't know what that means for the bottom. Now, 4 there means this is a 4 in the white cell. 5 or 8 there. So the last of these is 5 or 8. Now, I don't think it's helping with this sum at all. 5, 7 and 8 possibilities here. So, at least, well, 15 or 20, 22 or 23 in that cell. 5, 7 or 8 in that. So the other group is from somewhere between 18 and 7. And that really doesn't help. Typical. Never mind. Right, there's a 4 in one of those two. 8 is in one of those. These are from 5, 6 and 7. That's a triple. So the 8 in this column is here. That puts 8 in one of those cells. Not that useful. 4 and 7 must be. 7 must be in one of those two. So that's a 6. That's a 7. 7. That's not a 7. This is a 5, 6 pair. 9, 5, 8, 1, 3, 2. That can't be 5. This is a 4, 6, 7 triple. That's a 5, therefore. Why is this going so slow? There must be easier ways of getting through this. 5 there, let's put it in, and 6. 3 and 1 and 6 is 10, so that's a 7. 7 is 1 plus 6, so that's a 6. This I still don't know because I don't know the colour there. As I keep saying, we will get to that. 6 there makes that a 7 just by, well, by Sudoku, well, also by the arrow rule. And that's an 8. This is a 4. This row is done. 5. This box is done. Don't tell me this puzzle is done because I'm not going to believe you. That's not a 4. 7 and 6, in fact, are resolved. This is the last one in its row. It's an 8. 5 and 7 can be put in the central box. Oh, I'm getting excited now. This is not a 5. In fact, we can do 8 and 4 in this column. 8 in this box. This is a 5, 6 pair, still to be resolved. This must be 4. Yes. Haven't done those. Now we'll get to the clues in a minute. That's a naked single 5. All right. 95, 4, 3, 7, 1. This is an 8. Oh, and that's in the numbers. 7 there, 5 there, 8 there, 4 and 5. Might be able to finish off the grid and then do the last Japanese sums clues, perhaps. 6, 5, 6. Look at this. The grid is going to finish. 4 and 5. Right. Let us fill in these clues. 1, 2. That's a 5 at the bottom. This one, I don't know. Oh, this is 11. Of course, that's the last clue. This has been green for ages in the column. I hadn't realized. So this is 15. And that is adding 8 and what must be a 7, which is the 5 and 2. So the other cells are green. There we go. So that is the colouring. Let's get rid of the red and blue colouring so that we can see the full grid without my helpful colouring. Here is the grid of Math Pesto's puzzles with shaded cells. Now, that's an 8. This is an, oh, that's a 2. This is an 11 that I can't write because I can't do 2 numbers in the cell. That's also an 11. That one is a 10. I'm going to just colour them red, and that's a 15. And with those in place, that is the conclusion of this puzzle. I don't think there's any point pressing tick. Oh, it says it looks good. Or maybe this is only checking marked regions. Okay, well, that's fine. Excellent. Thank you, computer. You at least confirm I haven't got anything wrong with the Sudoku. I don't think I've got anything wrong with the clues. And I think that is the answer to this astonishingly long-rooted puzzle, in my opinion. I mean, well done if you've done that quicker. That's brilliant. I found that very tough. I know I missed some things for a while, like making that cell green, and every time I did find a deduction that had been waiting, it's annoying, but there's a lot to do there. Brilliant puzzle. As always, thank you very much for watching us on the channel, and I hope to see you again soon. Bye for now.